1 mole, 100 liters of the gas, 100 over 22.4, it will be 4 decimal something number of moles. Approximately it will be 4.5, rather it will be slightly less than 4.5 moles. So this is how we attempt these questions. Mole concept as applicable to gases with a statement that 1 mole of any gas occupies a volume of 22.4 liters at STP or NTP. This volume of 22.4 liters at STP, never say 22.4 only, 22.4 liters at STP. You have to say 22.4 liters at STP. So of it at STP. If conditions of temperature and pressure change, volume is definitely undergoing a change. We will study it in the states of matter, gaseous state. When we increase a temperature, the volume expands. When we decrease the temperature, volume decreases. We are given, for example, 1 liter of a gas at 27 degrees Celsius. If temperature rises, its volume will increase. If temperature falls, the temperature will decrease. Day temperature is around 35 degrees these days. We fill a balloon with air and put it in sunlight. Just a few minutes pass, there is a loud sound and the balloon has bursted because we filled the balloon in our room, put it under the sun where temperature is higher than temperature inside. As the temperature increases, the air in the balloon tends to expand. Balloon has elasticity, it will expand accordingly, but once its elastic limit is crossed, it will burst. With an increase in temperature, volume is bound to increase, but with an increase in pressure, it is going to decrease. One is Boyle's law, the other is Charles' law. We shall go into details of these gas laws. Boyle's law, relation between pressure and volume. Increase the pressure, volume will be compressed. Release the pressure and it will expand. Increase the temperature, it expands. Decrease the temperature, it contracts. Fill a balloon with air, put it in your refrigerator. After a few minutes, when you open the fridge, this much size of balloon is left because it has contracted. Molecules of air or gas filled in the balloon are in a state of constant random motion or movement called Brownian movement. These are having some kinetic energy. The kinetic energy is directly proportional to temperature in Kelvin scale. Just as we represented standard temperature to be 273 Kelvin, temperature in Kelvin scale, kinetic energy is directly proportional to that. As temperature increases, kinetic energy of molecules increases. Molecules continue to collide against walls of the balloon, but at low temperature, low kinetic energy, it has a little impact. When temperature increases, kinetic energy increases, molecules collide against walls of the balloon with increased kinetic energy. It puts increased pressure on walls of the balloon, and once it is unable to bear it, it explodes. So this portion we shall study in the chapter on states of matter, and particularly in that the gaseous state. Boyle's law says volume of a gas is inversely proportional to the pressure on it. Increase the pressure, volume is decreased. Charles' law says volume of a gas is directly proportional to temperature in Kelvin scale. When we write T, it means temperature in Celsius scale, say 27 degrees Celsius. When we write T, it is in Kelvin scale, 27 plus 273, 300 Kelvin. This is the difference. So volume will be proportional to this temperature and not this temperature. We have a gas which measures 100 milliliters at 300 Kelvin, and what will be the volume at 400 Kelvin? This we shall be able to solve through mathematical expression of Charles' law in the chapter on states of matter. So after adding more questions and more topics to more concept, this topic comes to an end. And as I said in the last lecture, part 4, we shall be attempting the laws of chemical combination. In this part, we have following laws. We have following laws. Number 1, it is law of conservation of mass. To conserve means to maintain. There will be no change. One substance is physically or chemically converted into another, and there is no change into mass. We take 1 kilogram of ice, melt it to convert it into water. Water will also weigh 1 kilogram. There will be change in some volume, which we shall discuss in the chapter on states of matter, but mass remains the same. We allow two different chemicals to interact and form new compounds. Form weight of the substances taken, which we call reactants, will always be same as weight of the substances formed, which we call product. This is law of conservation of mass. We will elaborate it. Second, we have the law of definite proportions. We could say law of constant compositions. Then we have law of multiple proportions. We have law of reciprocal proportions. The most versatile law, it is the law of reciprocal proportions, which will lead us to the idea of equivalent weights. This law will lead us to the idea of equivalent weights, which could be related to older barter system. When in villages or in poor families there is no cash, they take some wheat from their house to purchase something which is not wheat. Say they want to purchase sugar. A person from a house will take some wheat, the shopkeeper will weigh it, and according to weight calculate its price. This is, and now the customer says I need sugar in place of this. For that amount, considering the rate of sugar, he will give it sugar. The two weights will not be same. Weight of wheat and weight of sugar will not be same unless their rates are same. If we say wheat is 25, wheat is 25 rupees kilo and sugar is 40, then there will be relative change in their weights, and that is law of reciprocal proportions and Gay-Lussac's law of gaseous volumes. Gaseous volume. We shall take up in next chapter, but towards the end I will repeat. For any problem you can contact me. I will reply your queries.